Basic settings, you can set the direction of thrust, torque direction, open closed loop modes, number of optical stickers, sampling rate and other parameters. Thrust direction, the forward force generated by the engine and propeller. The back end of the test table points to the engine is the pull force. At this time, set the thrust direction to pull. The thrust display value in the real-time data is positive number. Set the thrust direction is push. The thrust display value is negative number. The backward force generated by the engine and the propeller. The engine points to the back end of the test bench is the push force. When setting the thrust direction is pull, the thrust display value is negative number. Set the thrust direction is push, and the thrust display value is positive number. Torque direction. The left-hand spiral theorem with the pull direction is CW, clockwise rotation. The right-hand theorem is CCW, counterclockwise rotation. Select CW. CW steering propeller torque will display positive number. CCW steering propeller torque will be displayed as negative number. Select CCW shows the opposite polarity. Shaft power calculation enables. Choose to use the pulse speed or optical speed to calculate the shaft power. Open loop or closed loop mode. Open loop mode means that the test bench will not lock the engine due to communication disconnection and can be connected through software. The closed loop mode is the opposite. After the communication with the host computer is disconnected, the test bench will automatically lock to ensure test safety. Generally, the open loop mode is used for long-term testing or poor communication conditions. Among them, the closed loop mode is the normal test mode. The relay mechanical switch in the electric control box should be set to the engine off state. That is, the ECU is powered. The igniter is in the off state, off. At the same time, the default state setting of the relay on the software remains consistent. Open loop or closed loop mode switching. Please turn off the power of the collection box before switching. Then, switch the mechanical position on the control panel of the electrical control box. In the open loop mode, the mechanical switch of the relay in the electric control box is adjusted to the engine ignition state. That is, the power supply of ECU number 1, ignition 1 of number 3 is set to the closed state on. At the same time, the default state setting of the relay on the software remains consistent. Note, in the open loop state, after the test bench is powered on, the engine will be in an ignition state. Testers must pay attention to safety hazards to prevent danger. Open or closed loop cannot be set. Only the switch state on the acquisition chassis is displayed. Number of single loop pulses. The number of pulses emitted in a circle at the pulse speed, similar to the polar logarithm of a brushless motor. It must be set before the test. If the number of pulse per cycle is set wrong, the pulse speed measurement error will occur. Number of stickers refers to the number of reflective stickers posted on the propeller or engine when using the speed of optical measurement. For example, two-blade speed measurement, the general posted reflective sticker is 2. Input 2 in the optical sticker number, such as the 3-blade speed. Generally posted reflective sticker is 3 in the optical sticker number input 3. It must be set before the test. If the number of optical stickers is set incorrectly, the optical speed measurement error will occur. Number of stroke. The number of strokes of the engine cycle and used to calculate the effective cylinder pressure. Engine displacement. The total engine cylinder volume used to calculate the effective cylinder pressure. Fuel density. Fuel density used to calculate the fuel consumption rate and specific fuel consumption parameter. Propeller diameter. Here the propeller diameter input value used to calculate the thrust coefficient and the power coefficient. If the user does not need to measurement the related parameters, it is not required to set. Sliding ratio, fuel to oil ratio. Sampling rate refers to the data acquisition frequency of the data acquisition box. The standard version is 10 Hz. The 100 Hz version can compatible with 10, 50 and 100 Hz. And the random noise will increase with the acquisition frequency. It is recommended to use 100 Hz for testing sweep frequency and response, and 10 Hz for other tests. Logging rate refers to the recording rate of raw data, log. The 100 Hz high-frequency acquisition version can support 0.1, 1, 10, 50 and 100 Hz. And the 10 Hz version can select 0.1, 1, and 10 Hz. The throttle linearity setting. In the throttle linear setting, multiple linear correspondence can be realized for the PWM output frequency. Throttle 1 opening and the corresponding PWM, throttle 2 opening and the corresponding PWM. By adjusting the PWM linearity, the linear correspondence between the throttle curve and the valve opening can be realized. Frequency of PWM refers to the update speed of PWM signal. Range of 50 to 500 Hz. General remote control is 72 Hz. Flight control is 400 Hz. Rather standard signal is 333 Hz. Theoretically, the update speed change will not have much impact on the control system. Throttle 1 opening refers to the air door opening. Generally from 0 to 100% throttle corresponds to the air door and the air door fully open. Throttle 1 PWM. The throttle valve controls the actual signal of the steering gear, which can adjust the throttle in a linear relationship with the linearity. Throttle 2 opening refers to the valve opening. Generally from 0 to 100% throttle 2 corresponds to the valve fully open and closed. Corresponding PWM. The shutter controls the actual signal of the steering gear, and the throttle 2 and the shutter are linear by adjusting the linearity. Relay settings. Relay settings include ECU power supply, electric start, ignition 1, ignition 2, oil pump 1, oil pump 2, servo power supply and alarm, in total 8 modules. The default state of the relay should be consistent with the relay switch in the electric control box. Relay lock reset setting. Software lock, ignition prohibited relay switch control state setting. First, third, fourth, fifth in the software relay setting correspond to IO1, IO3, IO7 of the relay switch in the electric control box. Note: the default state of the relay should be consistent with the relay switch in the electric control box. Safeguard. In the safeguard, you can set protection for parameter values such as thrust, torque, optical revolutions per minute, pulse revolutions per minute, fuel consumption, temperature, etc. There are 2 modes of safeguard. One is alarm. After selecting, when the test value reaches the protection value, the software will execute an alarm. The real-time data display position will turn red and flash, and the device will sound an alarm, but the throttle lock operation will not be executed. The other is throttle protection. After selecting, when the test value reaches the protection value, the alarm will be executed and the throttle lock operation will be executed. When the throttle is lower than 20%, the software will directly lock. When the throttle is higher than 20%, the throttle will slowly drop to 20% and then perform the lock operation. Test info. The test info includes engine model, propeller model, drive model, tester and other information that needs to be noted. Users can choose to fill in according to the test situation, and the output test data will simultaneously record relevant information. Auto test. The auto test includes 7 test modes: increase, cycle, custom, sine, linear, step, and frequency sweeping test. Users can select the test mode according to their needs, save the parameters, and click Auto Test after Allow Fire Up in the control window. The software will automatically record the data. Data setting. There are multiple data channels that can be set in the data settings. You can select the box in front of Real-Time or Log to display the data in the Real-Time data window and storage log. The initial version has preset general data parameters. Unless there are special parameters or customized parameters that need to be tested, users generally do not need to set them separately. Factory settings. The parameters in the factory settings, which is required a password to set it. Users do not need to set them separately. Custom setting. In the custom settings interface, a 1/8 corresponds to the ADC 1/8 interfaces of the acquisition card, of which a 1/4 is the system default sensor and cannot be modified by the user. For a 5/8, customers can connect different analog sensors 0 to 20 mA, plus or minus 5V, and enter the corresponding name, unit, and decimal place to be displayed, and the data can be displayed in the software interface. Similarly, T1 T8 corresponds to the 8-channel temperature of the temperature acquisition card, and users